We have questions from homeworks. I think last time they assigned like 1 through 6 and then worksheet 1, I think, right? Bella.
Could you just go over like the basic question? I just kind of need like a little refresher. Yeah, me too.
Yeah, sure. Do you just want to like do one of them from worksheet 1?
That'd be awesome.
That's fine. That's what this time is for.
I understand it's important. It's just a little hard to understand.
It's okay. All right. So let's maybe do number 1. Yes?
Perfect.
Okay. All right. So the first thing I want to do is figure out which quadrant I should be looking for my answer in. So I remember on the unit circle, tangent is y over x. So when I have a fraction that's negative, that means either y would be negative and x would be positive, or y would be positive and x would be negative. Everybody agree with that? Now, the place where y is negative and x is positive, that's like down there, right? So that could be quadrant 4. And the place where y is positive but x is negative would be up here in quadrant 2. Then, or next, I'm going to go and I'm going to look at that interval that my answer needs to lie between, pi and 2 pi, and figure out what 2 quadrants are covered by those angles. So if I notice that both these angles, pi and 2 pi, are positive, so I know I'm going to be starting at the positive x-axis and going counterclockwise. So a half a pi, 1 pi, 1.5 to 2. So we covered quadrants 3 and 4. Everybody cool with that? So what I've learned here is that the answer I'm looking for lies in quadrant 4. So it asks me to use the unit circle, so let me pull up a unit circle here real quick. Drop one of those in. Bloop. All right, so I'm going to be looking in quadrant 4 on my unit circle, and I'm going to be looking for where y over x is equal to -1. So y and x have to be the same thing, just differing by a negative sign to get -1 there, right? Okay, so I go to quadrant 4. And, well, this is the spot, right? That's what I'm looking for. The x is positive root 2 over 2. The y is negative root 2 over 2. So my answer should be 7 pi over 4. And I'm done. That's it. So again, you figure out what quadrant you need to look for your answer in. You go to your unit circle, pull the answer, and assuming that, well, the only thing additional thing that might come up is you got to make sure that your answer here does lie in the interval, right? So any additional step might be to just having to add or subtract 2 pi to that number you pulled from the unit circle to make sure that it lies in the interval. But 1 3/4 pi is definitely between 1 pi and 2 pi, right? 7 pi over 4 is 1 3/4. 7 over 4, 1 3/4. That's definitely between 1 and 2. So I know I'm good there. Where that might come up is a problem like, none on the first page, like number 11, right, where we're looking between 3 and 4 pi. There, the number you pull from the unit circle won't be between 3 and 4 pi. You'll have to add 2 pi to that answer. But that's the only additional complication that kind of can come up. Does that refresh our memories a little bit? I know it's been a couple of days. Were there other questions? Bella, are you satisfied with that?
Perfect.
Okay.
All I need. Thank you.
Sure, no problem, anytime. That's what the question time is for, right? Others? Cheyenne, that did it for you too?
Sort of a little bit. I think I still need to go through it since I wasn't here in class. Like I'm gonna rewatch the video.
Okay. Okay. We'll have some time at the end that if you're stuck on some stuff you can ask about too.
Okay. Because I was like really busy over the weekend, so I didn't really get much time to go through this. So.
That's okay. That's part of the reason why we record them, right? Is so they're there when you need it. Okay. So still staying in section 4.1 here. So here we're going to ask a new question. Where theta is equal to cosine inverse of negative 0.11, and theta is between 2 pi and 3 pi. Notice in the directions here, I don't say find the exact value for theta or give any indication that you should be using the unit circle. And in fact, there's a problem you cannot do with the unit circle. The reason I can tell that right away is that negative 0.11 is not a number that's a coordinate on the unit circle. Is everybody okay with that? Okay. So what am I going to use if I can't use the unit circle? My calculator. So I'll be needing to use my calculator to retrieve the angle. Now, I have to make sure I'm doing this correctly because as we pointed out on the first day, when we built this inverse function, the inverse function on our calculator can't output any angle for us, right? We're stuck with a really narrow range of outputs. So I have to set this up the correct way so when it comes time to punch stuff into the calculator, the correct answer kind of tumbles out for me. Everybody's okay? Ready to watch the process that we're going to use? The start is going to be just like what we did for the previous type of problems. I want to start by identifying the quadrant that the terminal side of my answer needs to lie. So I know that theta equals cosine inverse of negative 0.11 is the same thing as just saying cosine theta equals negative 0.11, right? That's just kind of our definition of inverses, is that you can go back and forth just saying that. And I remember that on the unit circle, cosine is x. So where is the x's negative? Well, that happens over here, right? Everybody agree with that? That's where x is negative. So that would be quadrants 2 or 3. So far, so good. Now I'm going to go to the interval in which my answer needs to lie. I always start drawing my angle on the positive x-axis. And because my angles are both positive, 2 pi to 3 pi, I know I'm going to be rotating counterclockwise. So each quadrant is a half a pi. So half a pi, 1 pi, 1.5 pi, 2 pi, 2.5 to 3 pi. So those angles cover quadrants 1 and 2. Which quadrant does my answer lie in? Quadrant 2. So now I'm going to draw a picture of my answer. This is the point where it's going to be a little bit different than what we did before. So I'll draw my initial side and my terminal side. They're somewhere in quadrant 2. Everybody's okay with that? And now I'm going to draw the rotation marks for this angle theta. So again, when I draw my angle theta, since I know it's a positive angle, because it's between 2 pi and 3 pi, I'm going to be rotating counterclockwise. So a half pi, 1 pi, 1.5 pi, 2 pi, and now when I run into my terminal side, that's where it's going to stop. So 2.5, and then my answer is there. So this was like 2 pi over here. This was like 2.5. This would be like 3 pi over there. Is everybody okay with how I drew the picture? Okay. So what I'm going to do now is I'm going to define a new angle that's called a reference angle. And that's going to be the angle formed between the terminal side of my theta and the x-axis. This new angle I'm going to call phi. And that angle phi is always going to be between the terminal side of my angle and the x-axis. Okay, let me say that one more time. The phi is always formed between the terminal side of my angle and the x-axis. So now I'm going to write an equation using the values that is formed on the x-axis, part of the x-axis that makes up my phi, and my theta. Okay, so I'm going to write an equation involving those three values. So if I look at this picture, is theta bigger than 3 pi or smaller than 3 pi? Look at your picture. Look at where theta ends and look at where 3 pi is. Is theta bigger than 3 pi or smaller than 3 pi? It's smaller. Why is it smaller? Because it doesn't go past 3 pi, right? It stops before it gets to 3 pi. Everybody agree with that? How much less than 3 pi is theta? How much more do we have to go to get to 3 pi? Phi, right? That angle that we labeled phi and highlighted in green. So since theta was smaller than 3 pi, we're going to be subtracting. And how much are we going to subtract? That angle phi. Is everybody okay with that? So we said theta was smaller than 3 pi. So to find theta, we need to subtract something from 3 pi. What are we going to subtract from 3 pi? That angle phi, which is the rest of the way to 3 pi. If you look at our picture, right? Is everybody okay with that? This is usually the trickiest part, is getting that part right, whether we should be adding or subtracting. So if I can figure out what phi is, then I can find theta. Everybody's okay with that? So to find phi every single time, all we're going to need to do is take the absolute value of whatever we're taking the inverse of in the original problem. So I'm going to take cosine inverse of the absolute value of negative 0.11. And now it's just going to be calculator time. So to type this into my calculator, what mode should my calculator be in? Radians, very good. Why radians? What about, from what I've written down tells me that I need to be using radians rather than degrees? The directions might tell you, but otherwise, if you just look at the work here, we can tell that we need to be using radians. The reason is, all our quadrants we wrote in radians, right? We used 2 pi, 2.5 pi, 3 pi. We didn't use 360, 450, 720, right? Or 540, excuse me, not 720 is the next one. Okay, so let's just make sure we're in radian mode. And then we'll do 3 pi minus cosine inverse. And I'm not going to bother to type the absolute value operation into my calculator. I'm just going to do the absolute value in my head because it's 0.11, right? There's like nothing to do almost. I just have to drop a negative sign if there's one there. Whoop-de-de-doo. So my answer should be 796 or thereabouts. Now, you can check this. To check this answer, you need to check 2 things. So there's 2 things you have to check. Okay? The first thing I need to check is to make sure that angle theta satisfies that equation. So if I do cosine of that angle, I better get negative 0.11 back, which I do. Great! That's step 1. The other thing I need to check is to make sure that that number is in between 2 pi and 3 pi. So I'm just going to go into my calculator, type in 2 pi. So 628 is smaller than 796. That's good. And then 3 pi. And 9.4 is bigger than 796. So I'm quite certain I have the correct answer because it satisfies that it gives the cosine of that angle is negative 0.11 and that angle is in between 2 pi and 3 pi. What do you guys think? Is that okay? Let's do another, yeah? All right. Oops. Oh, I don't want to do this yet. Hold on. I don't want to do a negative one yet. Let me do another. Do that. Okay. Process remains exactly the same. I begin by figuring out what quadrant the terminal side of this angle theta needs to lie. So I know that if theta is equal to the tan inverse of 2.7 or 2.37, that's the place where tangent theta needs to equal 2.37. On the unit circle, tangent was y over x. When y over x is a positive number, what does that mean about the signs of x and y? Either they both have to be positive, or they both have to be negative. Everybody agree with that? Positive divided by positive is positive. Negative divided by negative is positive. What quadrant is x positive and y positive? Quadrant 1. What quadrant is x negative and y negative? 3. Draw yourself a picture if you have trouble with that. Okay. Now let's figure out what quadrants are covered by 5 pi over 2 to 7 pi over 2. So again, we start our rotation on the positive x-axis because the two angles, 5 pi over 2 and 7 pi over 2, are positive angles. We begin by rotating counterclockwise, and each quadrant is a half a pi, so I'm just counting. So half a pi, 1 pi, 1.5, 2, 2.5, that's 5 over 2, 3 to 3.5. So that covered quadrants 2 and 3. Where does our answer lie? Quadrant 3. Everybody feel good so far? Just like the previous problem so far, right? The previous homework problems start the exact same way. This is the point where it diverges and we do something a little bit different. So I'm going to draw my answer, where I've drawn my initial side on the positive x-axis, as always, and draw my terminal side in quadrant 3, just like we've concluded above. Now I'm going to draw the rotation marks for my theta. So I need to go past 2.5 before I can stop at the terminal side. Everybody agree with that? Because I know that it has to be at least that big. Because that's a positive angle. Which way do I start rotating? Counterclockwise, that's to the left. So a half, 1, 1.5, 2, 2.5, 3, and then we ran into that so we can stop. So again, this would be like 2.5 pi. This would be like 3 pi over here. And this one down here would be 3.5 pi. So you can see that our answer is definitely between 2.5 pi and 3.5 pi, right? With the picture we've drawn. Everybody's cool? So that's our angle theta. I'm now going to draw my reference angle. That's my angle phi. That has to be between the x-axis and the terminal side of my angle. That means it has to be here. Is everybody okay with that? All right. So now I'm going to relate theta with 3 pi, the piece of the x-axis that's also a part of phi, and phi. So those are the 3 things I'm going to use to write my equation. So I'm going to ask myself the same question. I'm going to compare theta, this time with 3 pi. Is theta bigger than 3 pi or smaller than 3 pi? So look at the picture. It's theta's bigger than 3 pi because I see that theta goes past 3 pi. Everybody see that? So 3 pi would have ended like right here, but we kept on going. So it's definitely bigger than 3 pi. So that means that I'm going to have to add something to 3 pi to get theta. How much further past 3 pi did theta go? Went phi past, right? because this angle here is specifically phi. That's the part past 3 pi. Is everybody okay with how I wrote that equation? Notice this time we added phi instead of subtracting. How are we going to figure out whether we add or subtract? Looking at the picture we draw, right? The picture is going to tell us whether we should be adding or subtracting, depending on whether, like phi is before, before theta ends or after theta ends. How do I calculate a phi? It's just going to be the absolute value of whatever we were taking the inverse of. And then it's calculator time. Now, am I going to bother with the absolute value in my calculator? Heck no, guys. I'm just going to do that stuff in my head. So I get about 1060 then. So far, so good. Let's check this though, right? Do you remember how to check it? So if I go back up here, I want to make sure tangent of that angle gives me 237. So tangent of the answer gives me 237. That much is good. And that 1060 needs to be bigger than 5 pi over 2 and less than 7 pi over 2. So let me type both of those into my calculator here. 5 pi over 2 is 7.8. Definitely bigger. 1060 is bigger than that. And then 7 pi over 2 is just about 11. 1060 is definitely smaller than that. I'm convinced I have the correct answer, is it satisfies both requirements, right? Is this feeling okay? A little bit complicated, but not bad, right? What's the underrated skill here? Gotta be able to draw this picture, right? You gotta be able to draw that picture. Why do I need that picture? It's how I know what to type into my calculator, right? Gotta be able to do that. That's the underrated skill. That's probably the hardest part, is getting the picture right. Yes, Elise?
Will the picture be required on like a test or quiz, or do you just kind of need it? You want to do the problems?
Well, I would say it's tough for me to assign any partial credit without it, right? So again, if you show me what you do and you make a mistake, I can be like, oh, okay, I see what your mistake is. Yeah, you basically had it. I can give you like almost all the points. If all I have is the wrong answer, what can I do with that? I can't assign you any points because I don't know what you understand or not,
Okay.
right? So like, no, I guess you don't need it, but if you get anything wrong, I can't help you out at all.
Yeah.
You know what I mean?
Yeah.
Yes,
I know
Ruthie.
that.
Of course, yeah. Oops, can't do that. Actually, hold on. I want to do this 5 to 7. Bye. Have a good day. All right. Now notice there's a complication here. What do you notice right away that's different about this one than the previous ones? cosecant, right. Oops, I forgot to write the theta equals there. I'll sneak it in. Do we have a cosecant inverse button on our calculator? No. So we're going to have to figure out how to resolve that piece. Okay? So we'll start the same way. I can say that cosecant theta is equal to 5.61. Now, if I remember all the way back to chapter 2, I know that was a long time ago, but nothing goes away in trig. I remember that cosecant was related to sine, cosine, or tangent. Does anybody remember which one it's related to? Sine. And do you remember how it's related to sine? It's a reciprocal. Very good. So this would be something that if you don't remember this, this would be a good thing to put on your equation note card for the exam. If you don't remember the reciprocal identities, that's cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. I would write those down for my note card. Those are good things to remember. Elise? No, not quite. But what we can do is we can take the reciprocal of both sides here. And now that I've written in terms of sine, now I know what to do, right? What is sine really the same thing as on my unit circle? It's the same thing as y. And where is y positive? What quadrants? Quadrants 1 and 2. And really, since I have this, that's going to allow me to say that theta equals sine inverse of 1 over 5.61. So that's what I'm going to be using in my calculator later. But I have a little bit of work to do. Does anybody see a relationship between these two expressions or those two equations? Yeah, so I swapped out the reciprocal function. I swapped out cosecant for sine, and then just took the reciprocal of the inside, right? Do you need to show all the algebra that I showed there? No. Could you just remember that shortcut? Yeah, and if that's something that you felt like would be helpful to put on your note card, that would be a good thing to put on your note card. So you don't have to do that algebra every time. Is it helpful when I'm pointing these things out as we're going? I don't know if anybody started to write their note cards. Well, when you swapped out the reciprocals here, you have to make a reciprocal there. Right? That's all we're saying. So you can avoid having to do that out, remembering all that algebra. If you just remember, like, that's how it has to work, you know. And however you make a note of that, I don't know, you know, like, that's up to you. All right. We need to do the same thing now over here. We just need to figure out what quadrants are covered by those angles. So they're all positive, so we're just starting on the positive x-axis and going counterclockwise. Half, 1, 1.5, 2, 2.5, 3, 3.5. That covered quadrants 2 and 3. So our answer lies in quadrant 2. So I draw my initial side, my terminal side. Rotate counterclockwise, half, 1, 1.5, 2, 2.5, answer. So there's my theta. So these spots would be 2.5 pi, 3 pi, and 3.5 pi. My phi then is going to be right in here. So how do I write my equation? Which one's bigger, theta or 3 pi? 3 pi, so I should be subtracting from it to find theta. How much should I subtract? Phi. Great. And then how am I going to get my phi? I can't do cosine or cosecant inverse, but I can do sine inverse. Oh, 261, not 251, dumb. That ought to do me. And again, I'm not going to bother with the absolute values. I'm just going to do the absolute value part in my head. So that should be about 903. So I'll check that. I want to check to make sure cosecant is, well, maybe not really even cosecant. I'm going to check that 1 over sine theta gives me 561. And then that 903 is between 5 pi over 2 and 7 pi over 2. So, oh my goodness, guys, look what I did. Hey, Captain Dum Dum, look at this. What did I type in? I put 261, not 561. That should be 924. Excuse me, guys. Good thing I checked, huh? All right, I'll try that again. So that works. And then got to just make sure that 924 is between 5 pi over 2 and 7 pi over 2. Definitely bigger than 5 pi over 2. Definitely smaller than 7 pi over 2. So I'm sure that that's my final answer. We feel okay here? All right. One more example, because there's one last tricky thing that can happen, right? We've talked, yes, Matt. Sure. We've talked about how to do the process basically. We talked about how to do the process if we get a reciprocal, one of the reciprocal trig functions in there instead of a regular trig function. The situation we haven't dealt with is if the interval contains negative angles. So this is the last situation that I want to talk about here. So here theta is tan inverse of negative 0.61, I'm sorry, negative 1.61, and has to be between negative 3 pi over 2 and negative pi over 2. So initially nothing changes. So again, tangent is y over x. Where's y over an x got to be negative? Quadrants 2 and 4, because only one of x and y can be negative. Right, if I have right? If I have two numbers that are dividing and one of them's, and I get a negative answer, only one of the two can be negative. So either x has to be negative and y positive, or y has to be negative and x has to be positive. So quadrants 2 and 4. Okay, we'll draw our picture over here. So again, we start on the positive x-axis, but because our angles are negative, which way do we rotate? Clockwise. So this is negative a half, and then to negative 1, and then to negative 1.5. So this was quadrants 2 and 3. Where is our answer gotta be?
Wait, isn't it more than negative 1.5? We go past it.
Right, we're between negative 1.5 and negative a half.
Sometimes negative 1.61.
I'm sorry,
It's based off negative 2. Based off
I'm using this,
oh.
right? That tells me what numbers that my answer has to be between. So my quadrant that my answer needs to lie in is quadrant 2. So draw our picture. So initial side, quadrant 2. But which way? Yes. I mean, I don't care what it looks like. You're just getting it in the right quadrant.
Okay.
So in relation to like what size it is, I just put it in the middle. I'm never going to grade you on that part because you don't know until you actually do the work. Like, you know, like how that should look. I just stick it in the middle somewhere so I have enough space to write around it. You know what I mean?
Yeah.
It's purely a neatness thing for me. Okay. Again, this answer is a negative answer, correct? Which way should I be rotating? Clockwise. So negative a half, negative 1, and then there's my answer. Everybody's okay with that? So there's theta. Here's my phi. So again, the three numbers that I care, or the three quantities that I need to relate to one another to get my equation is theta, phi, and this time negative a half. Or negative pi. Why did I say negative a half? I don't know. Okay. So I have to ask myself, is theta bigger or smaller than negative pi? Is theta bigger or smaller than negative pi? Well, if it was the same, it would have stopped there, right? You would want to say bigger, right? Because the angle goes past negative pi. That's wrong, though, because it's actually more negative than negative pi. So it's actually less than, even though it's going past. It's the opposite of what you expected, because as you go further negative, you're actually getting smaller, even though it's like negative 6 is smaller than negative 5 kind of thing.
Yeah.
Right? So it's like counterintuitive. So we're going to be subtracting from negative pi, and we'll be subtracting phi from there. So that's the only complication here. And that was what? Tangent of negative 161. And again, I'm not typing the absolute value in my calculator. I'm just doing that part in my head. So I get negative 416. And we'll check it real quick. So tangent of that answer better give me negative 161. Good. And then that definitely needs to be between negative pi over 2 and negative 3 pi over 2. So it's definitely smaller than negative pi over 2. That's great. And it's definitely bigger than negative 3 pi over 2. So I am good to go there. What do you guys think? I think this is enough for one day. This one skill is pretty important. I want us to do a good job on it. So 7 through 10. And then worksheet 2. This would be stuff that would be due on Sunday. What's Sunday going to be? The 6th, I think. I think that's right. You guys feel good? Take some time here and get started on this stuff. We get out at 1:40. Yes, one moment.